This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week is episode 662. We welcome Dr. Elliott Gall. He's an associate professor at Portland State University. And we're going to talk about particle mitigation, talk a little bit about gas phase pollutant mitigation, and looking forward to a great show. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget after the show to continue the discussion at afterthoughts.iaqradio.com, sponsored by First On Site. Our marquee sponsor is First On Site at firstonsite.com. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
All right, the Z-Man's out this week. He's going to be at a service for Passover, so he'll be back next week to join us live. I'll take care of the trivia question. And glad to report that Dawn Weeks, Ottawa, Canada, was the first to identify midnight at Greenwich Royal Observatory as the time-counting solar mean time begins. The IAQ Radio trivia question for today, April 21st, 2022, has been sponsored by TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigation at TSI.com. Here's today's question. Name the protective covering of silk or other fibrous substance spun by the larvae of moths and certain other insects in a cover for the pupa. All right. John, you're going to have to keep an eye on the answers on that one for me. Today's guest is Dr. Elliott Gall. He's an associate professor of mechanical and materials engineering department at the Maseeh College of Engineering and Computer Science at Portland State University. Dr. Gall's research and teaching interests center around developing new approaches that improve building sustainability through an understanding of the intersection of building energy use, indoor air quality, and occupant well-being. Welcome, Dr. Gall.
Thank you so much for having me. I've listened to your show for a long time, so it's a thrill to be here.
Well, great to have you. How did you end up at Portland State University there? Portland State U up in Portland, Oregon.
That's right. Yeah, we are located in Portland, Oregon. And I came here by way of, I did my graduate research at the University of Texas in Austin. I did a postdoc after that in Singapore. So I moved abroad for 3 years. I joined a research group out in Singapore that was a collaboration with Berkeley, where we were studying indoor environments, specifically in tropical climates. It was a great experience to live abroad and see, essentially a different sort of university system, a different sort of mindset for research. And after a few years doing that, started looking to come back to the US, applied to faculty positions, and applied to a number of positions, but PSU's application struck me because it was really the only one that I saw, at least during that cycle, that specifically said they were looking for an indoor air quality scientist to join their faculty. Others were more broad. So I thought, well, shoot, if I don't get this one, then I better apply for this one and give this one my all, because it feels like it's a strong alignment. So I applied, lo and behold, was selected, and here I am. So it's been a great place to, study buildings, and also it's a nice place to live. So that's nice too.
Yeah, big change from you. You came up in Florida, and now you moved to the West Coast. A little different problems on the West Coast, more forest fires and things like that. But I assume that's kind of changed your, to some degree anyway, what you're looking at.
It has, yeah, it absolutely has, and it was sort of odd that the fires problem, has sort of followed me to some extent. And I thought by coming, maybe naively, I thought by coming to the Northwest, Portland's known for being a rainy,
Yeah.
almost year-round rainy environment. And so I thought I was escaping the fires issue that plagues Southeast Asia every year. And so in Singapore, there's 2 months or 3 months out of the year when, palm oil plantations primarily are clearing land. So a lot of the fires are sort of man-made, but there are, fire smoke events in Singapore that persist for months. So it was a major air quality issue that we looked at as part of our research group in Singapore, doing measurements, looking at mitigation methods to remediate exposure to smoke in Singapore from largely Indonesia. And so when I came to Portland, I thought, well, this will be nice to have a break from all those, terrible smoke events for months of the year. The advice was stay inside, run an air cleaner. And lo and behold, we moved here in the summer of, I think, 2016, had a nice summer that year. And the next summer, had weeks and weeks of fire events in the summer here in the Northwest. So obviously it's been a long-standing, issue in the West. Fire is part of the landscape in the West, but obviously in the last few years, it's become a lot more, extreme and frequent.
Well, the reason I had been wanting to talk to you for a while now, but then I saw Dr. Rich Coursey. He did a summary of the National Academy of Sciences, had a workshop on particle mitigation and particulate matter. And I saw that you gave a presentation there, and I thought, this would be a great time to get you on and maybe talk a little bit about what you did at that particular workshop.
That sounds great.
John, can we pull up the slides we were looking at before? Let's kind of give them an overview of what your presentation was about, to start with mitigation of fine particulate matter exposures in schools. So how do we make things a little better in our schools, huh?
Yeah, that's right. So this was, building on some work that we did here in Portland, Oregon with one specific school. And as part of that, we looked to, sort of characterize issues more broadly and look at what other schools and school districts might be doing for this particular population of, children in schools. Obviously a susceptible population. We really should be investing in good indoor environments in schools for a whole host of reasons.
John, let's go. Go ahead. I'm sorry.
No. I was going to say that includes, mitigation methods, which was, one of the primary topics of this presentation.
Now, the pollutant in this case is, I don't want to say rare. It's very common throughout the country, but depending on where your building is sited, I guess, can be an even bigger problem. You're talking about TRAP. Can you tell us a little bit more about what that is and how important it is?
Yeah, absolutely. TRAP is sort of a convenient acronym. It stands for traffic related air pollution. And I think TRAP is handy because when we think about, vehicles as a source of pollutants, we're really talking about a complex mixture of particulate matter of different sizes, of different chemical composition, and also gas phase compounds. So, volatile organic compounds, things that you probably are familiar with, like BTEX, benzene, toluene, ethylbenzene, xylene. These are all, part of the matrix or the, mixture that we call traffic-related air pollution. And like you mentioned, this is a problem in urban environments generally, right? I mean, vehicles are a major source of air pollution to our cities, but for 15% of schools, which is a sizable, fraction of our learning environments, around, 6.5 million children in those schools, are located in very close proximity to a roadway. So less than 250 meters is, one of the thresholds by which we say you are a quote unquote near roadway school.
And how do we define a roadway?
Yeah, these are sort of major thoroughfares, either, interstate highways or large state highways. There is a threshold for vehicles per day. I don't remember off the top of my head. It's on the order of, tens of thousands of vehicles per day.
Gotcha. And then the known problems associated with being close to this trap include?
Yeah, I mean, a whole host of adverse health consequences. So things like, you see increases in asthma diagnoses in populations that are near roadways, right? Other respiratory and cardiovascular effects. Recent studies also link it to decrements in learning, right? So students learn better when they have good air quality, right? So this was a large study in Spain that I'm showing there in the lower right that basically says, in cohorts that have lower levels of traffic-related air pollutants, scores of working memory, right, are better, right? And that's, I think, something that's been borne out in a number of studies that, our air pollution actually affects our thinking as well as our health.
The graphic of the United States there on the left, I was a little surprised to see that there's a lot of schools closer, if I'm reading this right, closer to these, highways in places like Kentucky and West Virginia and up in the Northeast. I was expecting more of that in California.
Mm-hmm. Yeah, that's a good observation. I can't explain that, but yeah, I'd be curious to. I noticed that as well, right? You see this concentration, yeah, in Kentucky and sort of the middle region there over in the east, and I don't have an explanation for that. It's a good
Hawaii.
Good Hawaii, you can sort of maybe rationalize. Not a whole lot of land in Hawaii that's buildable, so maybe everything's a little more compact.
Gotcha. Let's go to the next one, John. Okay, so this kind of gives us an overview of the different types of pollutants that become a challenge for near roadway schools. Can you kind of run us through this one real quick?
Yeah, real quickly. I think the point of this slide is basically to articulate, that like particles is not, a monolith. It's not one thing when we say, that we have elevated particulate matter, and, they're sort of different subcategorizations that might be useful for a variety of reasons, including, we know that some types of particles cause, have an outsized effect compared to others in terms of health consequences, right? So in the bottom left, I'm showing a plot of, a plume of black carbon that's moving from the roadway, impacting the school where we did our field study. That's that big red blob is an elevated mass of what's called black carbon moving from the roadway to the school. Black carbon is a good proxy for the particles that come from diesel combustion, that comes from other combustion processes as well, but in large quantity from diesel combustion. Diesel particulate matter is a known human carcinogen. So, that subset of particulate matter is one that if it's elevated, you want to be aware of that. Ultrafine particles, I think in the past few decades, we've learned a lot more about those very small particles and how they can penetrate deeply into the lung and enter the bloodstream and potentially cause, again, outsized health effects. So that's that middle portion there. The one on the bottom right is the PM 2.5, the categorization of particles that, is one that is federally regulated in outdoor air and probably one we're all more familiar with. The point of these three plots is basically to show that the type of particle matters when you're trying to characterize a particular source. So in a near roadway environment, we see a lot of black carbon and a lot of very small particles, some exacerbation of PM 2.5, but PM 2.5 comes from a lot of places, right? So it's not so uniquely identified with the roadway.
Interesting. All right, let's go to the next one, John. I think this is the one we were going to skip over that, I believe, and go, unless you wanted me to stop.
No, I think we can make the point here. And the point is that, in addressing near roadway environments and the particular air quality challenges for buildings located near roadways is that, you have a specific source, what we call a line source, which is the roadway, right? And it's a very simple point. As you get closer to that source, you would expect levels of the air pollutants from that source to be higher. And that is borne out in study after study, which is what this plot shows.
Let's go to the next one.
Yeah, practical impact of that. And it's one that I think anybody could come up with. And it's sort of like ingrained in our brains, right? If something is producing irritating or things that, are harmful, well, you should get away from it, right? So it's a simple concept here. But we bore that out in some measurements in a school here in Portland, Oregon, that was being renovated, right? So boxed in red is a school in Portland called Harriet Tubman Middle School, where we did a field study. The school was being renovated, and prior to the renovation, where that blue dot is one of the outdoor air intakes for the school. So maybe not the ideal place to bring in outdoor air to the school, immediately adjacent and facing the interstate. So we thought, well, let's just take a few days of measurements and just see, how does the black carbon concentration, again, that good proxy for the combustion emissions from diesel, how do those levels vary at the blue dot from the gray dot? So about 70 meters farther from the roadway, from the highway. And again, it's this straightforward, but it's nice to see this borne out in data. The blue lines, we see a lot more black carbon adjacent to the freeway than we do on the surface street about 70 meters away from the freeway. And this is real rough, but it's about equivalent to putting a MERV 8 filter or so on the intake of your outdoor air that you realize just through dilution from moving away from the source. So it's sort of a passive, if you can achieve that really simple, low cost, continuous way to improve the quality of air that you bring in from the outdoor environment.
Interesting. And this school was being renovated and had a little more money than usual for certain reasons, I guess. Can you kind of elaborate on that a little bit?
Excuse me. Yeah, so there was a bond passed in the community to address environmental issues in building stock in schools in Portland. So the school did have some resources to put into issues like lead and water, asbestos in the building, structural renovations because we're in an earthquake zone here in the Northwest. And then one issue in this school in particular was this proximity, right? It was, no surprise to the community and the school district that there would be air quality concerns in this building. So they had some resources to invest in other mitigation methods as well. So active air cleaning systems were installed in this school, which we can talk about, but essentially in the air handler installed, a series of filters, MERV 8, followed by MERV 16 filtration, followed by an activated carbon scrubber in the school because of that bond. And to the school's credit, to the school district's credit, they worked with myself and a colleague, Linda George, who are both air quality scientists. We worked with a really great mechanical contractor who, we iterated with and discussed, how might we help solve this problem? School district put the resources they had available to them behind it. And as we'll see, I think in a moment, installed, in my opinion, a very effective air cleaning system in this school.
Let's go down a slide here, John. I think at least one, maybe two.
Yeah, I think we can skip this
I think
one.
we're going to go down one more.
Yeah, this just real quickly, this isn't specific to the school where we did our field study, but this is looking across other schools and other school districts that have installed air cleaning systems, active air cleaning systems. So this is looking specifically at can filtration systems be effective at reducing concentrations of particles in schools. So I just have basically a survey of the literature, and you see in general the answer is yes, right? We see removal effectivenesses of black carbon and PM 2.5 in schools that range from maybe 40% up to 80%. So in general, meaningful reductions, but wide variability, and that that's where you need a good mechanical contractor, a good design, a good implementation to realize a high removal effectiveness.
And this is comparing, you've got HVAC filtration and standalone filtration.
Yeah, so that's distinguishing between an intervention in the air handling system in the school. That's HVAC filtration. Standalone is, at least what I'm calling in this slide, like a portable air cleaner deployed into the occupied space of the classroom.
Okay.
So I tried to limit this to studies that were done in occupied real schools, right? So not theoretical calculations, not testing done outside of occupied hours. These are sort of realized effectivenesses when the building is being used as intended.
Okay. Next one, John. All right. This kind of summarizes a little better what you did for the school in Portland, I believe.
Yeah, that's right. So I mentioned that the ultimate design that was settled upon, and you can see in the upper left there, this is from Google Maps. Google's all-seeing eye gave us a nice ability to look at the renovation that ultimately was implemented. So on the left is pre-renovation, and on the right is post-renovation. So you see that substantial addition of, ductwork, and on the upper left there is the, sort of the core of the air handling system. So there's a single air handling system that serves the entire school. And so in that air handling system, if you scroll down or zoom out a little bit there, all the outdoor air that's brought into the building and all the return air is cycled through, a series of filters, the MERV 8 and MERV 16 filters. And then I think what really distinguishes this building is the installation of this functionalized carbon, which is, pretty rarely done in buildings. But again, that gets back to these discussions that we had that, focused on traffic-related air pollution as this complex mixture. So, particles are certainly elevated in a near roadway environment, but gases are as well. And many of the gases that are elevated in TRAP are of health concern. And so the school district was receptive to that idea that, we might want to be looking to intervene for a broader suite of air pollutants than might be typically done. And they did, right? And so we have some nice measurements that we can get to about not only the effectiveness of those particle filtration systems, but also those gas phase air cleaning systems.
Let's take a look at that, John. Scroll down a little bit.
Can skip this. Yeah.
Here we go.
Yeah, so this is a plot showing two things. On the left is a plot that many of you are, I'm sure, familiar with. This is predictions of removal efficiency of a filter as a function of its MERV rating. And these are sort of, extrapolations or interpolations from what information you get from, a test to determine the MERV rating. So you're looking over a broader range and more continuous, but essentially the idea being, higher MERV rated filters generally give you better removal efficiency. MERV 16 filter you see up there at the top of that plot, you should have pretty effective removal across, a broad range of particle sizes. And what I'm showing on the right, it's a little bit difficult to interpret without more time to explain, but these are measurements of one pollutant of concern, black carbon, which I've already mentioned, a particle phase pollutant. We took measurements in outdoor air, that's the red line, inside the building, right? So that's the blue line, what's coming back from the building. And then the green line is what's getting pushed out into the building from the supply air system. So if you do the math, right, what we're able to show with these measurements is that we're removing 85%. We have an 85% effectiveness of our intervention for black carbon. So that's a really good result from this system. We've substantially reduced black carbon exposures in this school because of this series of air cleaning systems.
Okay, let's go to the next one, John. Now, before we go there, Elliott, we show what happened with the black carbon. Do you also have, I don't recall if we have a slide in here with what happened with the fine particulate and the PM 2.5?
Yeah, I don't have a slide in here specific to that, but the takeaway is the same from what we showed on the black carbon slide. We were really effective at reducing ultrafine particle concentrations, so those very small particles less than 100 nanometers, and PM 2.5, generally very effective. This slide, I think, speaks to some of the nuances of particles and interventions and these metrics that result. For a compound like black carbon, right, produced at very high temperature from combustion processes, ideally there are no black carbon sources inside your building. If there are, you should be very well aware of them and either remove them or intervene with a specific exhaust system or something. But in general, there are not black carbon sources inside a building. That's distinct from something like PM 2.5, where there's a lot of different activities and processes that can produce PM 2.5. So generally, your intervention effectiveness is maybe a little bit lower for something that has strong indoor sources because they're being emitted directly into the environment. Black carbon's just coming from outside. All the air coming from outside in our building, not all, but close to all, has to pass through our filtration system before it gets in the building. And so what we're able to do in our school is basically, make that point mathematically. And we calculated, where is PM 2.5 coming from compared to black carbon? The ultimate takeaway is that for PM 2.5, a sizable fraction of the PM 2.5 sources are coming from people and the things they're doing in the building. So, we're not able to say specifically that you are emitting this much PM 2.5, but your presence, the way you're changing the building, the things you're doing, all have a substantial effect on the sources of pollutants to a building. And that's very different from a pollutant like black carbon, which again, shouldn't have indoor sources in the building.
It looks like it's pretty much equal to what you get from the supplier.
Right. Yeah, that's right. Right.
Interesting. Now, I wanted to ask on as far as the gas phase pollutant removal, how successful were you there?
Yeah, I think the gas phase air cleaning, I think is a little bit more complicated than and in part because it's not done as frequently. I think there's it's not as mature of a technology, but activated carbon can be effective. And I think the short answer is the gas phase air cleaning systems were on the whole very effective. We removed a sizable fraction of the gas phase pollutants that were entering from outside and from inside the building. Something on the order of 30 or 40% reduction in the source, right? Because we're trapping it onto the carbon scrubber. That varied a lot compound by compound though, right? It's not, you can't expect 95% removal efficiency for one compound. It doesn't mean you're going to get 95% removal efficiency for another compound because they have different chemical structures, different volatilities. It's a very complex mixture of gases. On the whole, carbon can be effective if designed appropriately.
And as far as the sources of this gas phase pollution, do you have something similar as far as a breakdown? What came from outside, what came from inside?
Yeah, we do. And the breakdown, I think, the general idea is not dissimilar. We made these calculations in another paper, and we showed actually that it's roughly equal between indoor and outdoor sources for this building for VOCs. And I think that's probably distinct from many other buildings. We're near a roadway. There's elevated VOCs in the outdoor environment in this building compared to other buildings. So generally speaking, there are higher indoor VOC levels in a building than outside a building, in part because there are indoor sources that create a larger fraction of the what you call the source apportionment to the building. It roughly broke down to be equal in this building across all the compounds we were able to measure.
We've got a text question. I want to kind of maybe reconfigure it just a bit. They ask, how does buoyancy affect dispersion, settlement regarding size and time? And we all know that, particles, PM 2.5, and in particular, the larger ones, they do settle out of the air. So were you able to differentiate between what was captured by the system you installed versus maybe what had settled out of the air?
So with this field study, we weren't able to distinguish that. What we were able to do was to ultimately, because of how we were able to make our measurements, we were able to basically calculate the overall source or removal that occurred as air sort of moved from the supply back to the return, because we were able to make measurements in supply, return, and outdoor air. So we weren't able to sort of tease out, right, like why there was a source, right? Well, it could have been there's a net source because you had a big source and a big removal, and then we had a small net source, right? Or it could have been that there was just a small net source to begin with, right? So we weren't able to tease out, the particulars of how things like, buoyancy that might be changing from occupancy to non-occupancy might have had impacts on the building specifically, but it is a good question, right? Obviously, there are removal mechanisms in the building that'll be impacted by what's going on in the building, and that'd be a great, sort of opportunity for a little bit more detailed study in the field. Field studies are tricky, right? We would have loved to have gotten more measurements inside the occupied environment, but it being an occupied school, we were fortunate to be able to get the access we did to make these measurements in an occupied school environment. It's fairly rare to have the opportunity to do that because, obviously we're concerned about learning environments for a whole number of reasons. And when you show up to a school with, big clunky devices, you say, I'm here to help, trust me, and I want to stick 15 hoses into your air handler, but trust me, so we were glad to be able to get the measurements we were, but with a little more access and a little bit more time, we could have done some of the things that I think the questions alluded to.
We're right about halftime. Can we maybe let's go ahead and summarize this one, and then we'll go into the couple more articles and papers I want to talk about in the second half. Is there one more slide in here that we needed to?
Yeah, there was a summary slide. I think, the last point was that there's some chemistry that happens that, this building had the unique ability to suppress because of that gas phase air cleaning system. So,
Right.
Particles and gases can be linked in interesting ways. So some of the things we emit into the building, so things like scented consumer products, are very chemically reactive. And if an oxidant from outside comes into the building, it can chemically react with those scented products and form particles, right? So, there's a complex interplay going on. And in this building, the carbon scrubber removed not just the organic compounds, but also many of those oxidants. So that was sort of an interesting finding from our study, is that we sort of had the ability to suppress this chemistry that is an indoor source of particles of concern.
It was an additional benefit that weren't, I don't think we were thinking, maybe you were thinking about at the beginning, but maybe.
Yeah, maybe not so prominently, right? It was, sort of, we were looking to target two different things, and, sort of in doing so, we studying the system came to the realization that, there are some secondary effects there that in this case, fortunately, were beneficial.
Let's go to that summary slide again, John. Kind of summarize things. Yeah. All right. So let's do a quick overview of the summary on this one.
Sure. Yeah. So I think the first thing we talked about is very obvious, right? Get away from a source if you can. I think that's intuitive. The second one we didn't have time to talk about, but this, comes with sort of understanding the nature of the air pollutant source you're dealing with. And so in the case of, traffic related air pollution, again, it's common sense that's variant throughout the day. And so one of the recommendations made to the school was to, maybe alter timing of activities, right? Because during rush hour in the morning and the subsequent hours immediately after that, that was when the worst air quality was experienced in the school outdoor area. We talked a lot about air cleaning systems, right? That's an active way that we can intervene. And in this, if designed appropriately, and this, I think, study showed it, can have a substantial effect on improving indoor air quality. I think this building has some of the cleanest indoor air in the state, despite being located in proximity to a freeway. And the last points, sorry.
Go ahead.
No, the last points being addressing indoor sources, and that might include, some of this chemistry and sort of understanding the chemistry that can happen in buildings.
I think there was another kind of outcome that we talked about earlier that maybe wasn't expected, because it is such a clean building now. They can use that as a kind of shelter for people that don't have the ability to get away from some of this wildfire and other types of contaminants.
Yeah, that's right. It's something we've talked about with the local Department of Health and the school district, and tried to help, encourage that and facilitate that connection. I think it's a great idea that, this is a resource, could be a resource for the community. It even aligns really well in time. Like if you think about the scheduling of school with the, let's say, scheduling of wildfires, right? School is out of session during the summer, so the building is largely vacant. That's the period of time that, especially in our region, when fires are most, likely. And so there's some, synergies there that I think, this could be some way that cities look to build, resiliency or capacity to help protect people.
And I can imagine that might help the school district with the ability to find kind of non-traditional funding for these types of things.
I completely agree. And it's a conversation that, we're still sort of trying to advocate for and push that. I think everyone agrees that, it could be a win-win. I think a lot of you got to get different government groups talking to each other and collaborating. I think those things take time, but I hope it takes off.
All right, let's go to halftime. We'll be back with the second half of our interview with Dr. Elliott Gall. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org, ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science, ACGIH.org, the Cleaning Industry Research Institute, see more deeply through science and research, CIRI science.org. The Indoor Air Quality Association, IAQA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, tsi.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, let's get back into the second half of our interview with Dr. Elliott Gall. Let's go, John, to that ASHRAE article for interpreting air cleaner performance data. What led, and you did this with, maybe you can mention your colleagues here, and what led to the development of this article?
Yeah, sure. So this was a sort of the result of some work that I've been doing with Brent Stevens at Illinois Institute of Technology, Mohammed Henadirjad, also at Illinois Institute of Technology, and then Delphine Farmer, who's at Colorado State. And so, we all have been interested in, obviously COVID has, everyone, whether they like it or not, has to be interested in COVID to some extent, for some reason. And obviously, air cleaning systems have taken a real important role in some of our non-pharmaceutical interventions to try and reduce the spread of COVID. And so this paper really came out of some other research that the four of us were collaborating on, where we're testing some of the quote unquote new kinds of air cleaners that are out there that are making really bold claims about what they can do in terms of cleaning the air, both for removing virus or deactivating viruses in air, and also addressing other indoor air quality issues. And so as we sort of were doing that research and trying to interpret what information was out there from a variety of manufacturers of air cleaners, we just really felt there was a need for us to kind of put at least our thoughts together on how we might think about making sense of the different kinds of data that are out there on air cleaning devices. And so, one of, I think, the major motivations for this is something that we saw over the past 2 years was a strong marketing push to get air cleaning performance data presented that says something like, 99.9% removal in 30 minutes, right? You saw a lot of advertising, and you've sort of always seen something like that in the indoor air quality community, or at least for a long time. And it can be a valid way of presenting, performance data, but, it depends on a number of factors, what that really means for you and your space. And so a big part of this was trying to kind of get a foundation out there for the different ways we think about air cleaning performance data, some of the standard test methods and how they're reported, and then, some of the other ways you can get meaningful data, but you need to manipulate that data to make sense of it and compare it to what might be happening in your building, or compare it to another air cleaner, for example.
All right, and then it's kind of tough just to do the key takeaways on this one because there's so much in this short article. But one of the things I noticed was you distinguish between additive and subtractive technologies, and you said that there's not always a clear, rigid line between them. And what do we mean by that?
Yeah, sure. And I think that's a really helpful distinction in thinking about, the air cleaners you might be considering. And so, our rationale was, that a subtractive approach is basically just seeking to target something harmful and take it out of the air, right? And so a great example of that is, a mechanical filter, right? It's trying to separate out particulate matter, sort of a physical process, taking those particles away from air, right? Activated carbon, you can think of as a similar approach for gases. It's trying to select out for organic compounds and take them away from air. What we were considering as additive systems are this sort of class of air cleaners that takes the opposite approach, really, right? It's saying we're going to inject something into the occupied space, and it's going to engage in some beneficial, in theory, or hopefully some beneficial process that is going to eventually deactivate or remove something, right? But step one is you got to add something to then take it away. And like you said, you can split some hairs here, right? So like a UV system, well, you're adding ultraviolet radiation somewhere with the hope of, deactivating a pathogen. So it's not always a perfectly clear distinction, but I think it's a useful framework, because when the idea is that, you're going to add something to the occupied space, that always puts me on alert, right? So, what are the ramifications of what it is that you're adding to the space? Because, generally what we want from air is oxygen, right? Our bodies are looking to take oxygen from air and to exhaust our metabolic products from our metabolism. And obviously there's some exceptions to that. You can get medicinal drugs into your body very quickly, and maybe in some cases you can conjure up a scenario where your lungs are going to serve as a delivery mechanism for something other than oxygen. But in general, our bodies, to be healthy, want oxygen from air, and that's largely it, right? So whenever anyone says, well, this system works by injecting hydrogen peroxide into the space, or hydroxyl radical into the space, or ions into the space, I think there's some important questions that you should be asking if that's step one of the air cleaning system.
And one of those important questions is, what are the byproducts of injecting whatever it is into that space?
Yeah, that's right. And so I think that's a logical question that should be answered. And one of the takeaways of our paper here is that, there are no established methods for doing that, right? For evaluating the byproduct formation from an air cleaning system. And that applies generally, right? The ANSI AHAM AC1 doesn't look to see if a portable air cleaner is causing some emission of a byproduct. And so I think there's a need for that, because there's a whole class of air cleaners that, there's a logical argument to be made that they're at, greater risk for generating byproducts because of the way they're intended to operate by changing the chemistry happening in your indoor space. A portable air cleaner with a fibrous filter in it, everything emits some small quantity of VOCs, but, I think that's not the intended mechanism of operation of that device.
Right. You're not intentionally injecting some VOC into the air.
Right, exactly.
Some radical of some kind. All right. Any other key points from that paper before we move on to I really want to get to this fire tips.
Yeah, I think in 30 seconds, the other takeaway is, like the other question you should be asking is, does the system work? Right. And so what we provided was, the sort of foundational math, and we tried to simplify it. We provided a spreadsheet tool that you can enter in the kinds of data you see from some manufacturer spec sheet to back out, the equivalent clean air delivery rate from an air cleaner that might not be tested in a way that the manufacturer is just telling you the clean air delivery rate. And so I think that was an important contribution, because we're trying to provide the tools for people to make their own decisions, right? Take this manufacturer data and, put it on equal footing with something that they can translate into their space, compare it to other air cleaners, and make an informed decision.
And I think we can get those into the blog, the tool that you're recommending there.
Yeah.
Okay, let's go to, I want to, and I'll get to that text question here during the roundup. But before we get there, I want to talk a little bit about some practical wildfire tips. You break it down into some real simple steps. Let's review them and then go into a little follow-up on that. So this is for wildfires and air quality inside your home. It's free online here. We'll put the link up, John. Maybe you can put it in the text. But tell us a little bit about the most practical way to create a clean room, I guess.
Yeah, this was a blog post that I wrote that was really born out of, practical experience. Like I mentioned, fires have been following me since 2013. Not to make it all about me, they're impacting lots of other people as well. But, just having dealt with this problem and having some indoor air quality perspective, I hope, eventually I just felt the need, I got to put all my thoughts down in one place, both for me and then, hopefully to share and help others sort of think through this. And so the idea, the EPA has a similar, approach. And, I sort of developed this at the same time that EPA had their thoughts coming out about what they call a clean room. So that's the EPA's language is, one approach is to think about developing a clean room in your home during a fire event. And I love the approach because I think, for episodic events like a fire, focusing your interventions into a smaller space in your home can really magnify their effectiveness, right? I mean, after the fires in 2020, you heard all these stories about, luxury homes with air cleaning systems is now the hot selling point for homes in LA. But I think in general, for most folks, you can get a big bang for your buck with some relatively simple steps for what hopefully is an episodic event by starting in a small area, right? So a bedroom is a good approach or a good place to start, because then your air cleaner sizing, scales with the volume of the space ultimately. And so starting with a smaller area, you don't need to spec an air cleaner for your whole home. You can look at a range of DIY options or lower cost commercial options that can really do quite a good job at reducing the particle levels in your space. So, if you're familiar with the ANSI AHAM AC1, rule of thumb, 2/3 rule, if you have a 150 square foot bedroom, you're looking for an air cleaner with at least a clean air delivery rate of 100 CFM. Right. And there are a lot of low cost options that can achieve that. And we'll talk about, hopefully have time to talk about a fun project in my lab that showed just how simple that can be. Yep. So, I mean, even if that's all you do, right? Like those are two very simple things, right? Like target a small space, size an air cleaner for the space appropriately. If you have the ability to sort of upsize it, get a bigger air cleaner than 100 CFM, you could run it, on a relatively lower setting with relatively lower noise. What we learned in 2020 is like these episodes, while you can use that phrase for a 3-week fire, a 3-week fire episode starts to feel like a lifetime. So having an air cleaner that's running at 60 decibels for 3 weeks and you're cowering in a bedroom for your mental health takes a toll, right? So I think it's really worth thinking about, how do I create a clean room that I can reduce my exposure, but also not drive myself crazy for what might be 2 to 3 weeks. And this is, the product of sort of living through that, right? My recommendations are, make sure you pick a clean room that has a window, right? Like you need, even during a fire, like being able to look outside and see sunlight is really important. Having an air cleaner that you can run that has relatively low noise, again, really important. The third step that I had from this blog is that, you can sort of boost the effectiveness of your air cleaner if you do some basic air sealing in the space that you're in. So I got these, it's a sort of low res picture, but it comes to like $1 a window. These sort of 3M makes a product that, is sort of really quick to install with double-sided tape, seal around the frame of the window. And, in my measurements, it substantially reduced infiltration and reduced the particle levels in the space substantially, almost doubling the effective, air cleaning effect of my combination of an air cleaner and some air sealing around the window.
Well, that goes back to the two charts we saw. Go up a little bit more, John, to those two. Go to the first one. So this was indoor air. Go ahead.
Yeah, this was just the effect of adding an air cleaner, right? For the assumptions of the model I built here, but this is adding an air cleaner to a small volume a bedroom.
Okay, and then go down, if you would, John, to the next one. And this is, I believe, the one with air sealing.
Right. So the blue line. Now we've added the effect of just reducing infiltration, air sealing around windows in the bedroom, reduce infiltration. You boost effectiveness, right? And you start to get diminishing returns, depending on how you think about it, the order in which this happens. But the target here, the idea that I set for myself in this blog was, can we hit an indoor level that's below the annual average PM 2.5 target, right? And the answer is, you can, right? You can do it.
And I'm wondering, could you use similar concepts to build a safe room from COVID? If other people in your home have COVID,
I
use
think
the same concepts.
There's some good guidance out there on that. Now, obviously, the source of the pollutant in that case is coming from inside the building instead of outside the building. So, air sealing your enclosure, maybe not the first thing you do. You sort of would want to try and create a negative pressure room if you're trying to isolate someone in your home, and you can do that pretty easily with a box fan, for example.
Yep.
But yeah, same idea. Some of the advice I've seen out there that I think is logical and sound is run air cleaning systems in the space where the infectious person would be. Try and manage the intrazonal flows by creating a negative pressure space, and you can do that pretty easily with a box fan.
All right, your group also did some work on a low-cost DIY, do-it-yourself, rapidly deployable air cleaner for use in emergency situations. That was an EPA contest. You were one of 5 winners. Tell listeners a little bit about this.
Yeah, this was a really fun project.
DIY, huh?
Yeah, very DIY, and it sort of one of the things that this came from is I think we all learned a lot during COVID. And at the start of COVID, I don't know if folks, I'm sure remember, there's a lot of debate about, whether cloth masks had any benefit or whether we were all just wasting our time, right? And I think the prevailing wisdom early on was, if you're not wearing an N95, there's no point, don't bother. And I think we all sort of changed tack on that somewhat quickly over the first few months of the pandemic. And I have to admit, my thinking on that changed, right? As I started to see more data and see the impacts of, everybody wearing cloth masks, can have, maybe it's not, the ultimate intervention, but it can have a positive effect. So I sort of learning that lesson and sort of, having a little bit of, having to, eat crow a little bit, I guess, except you're being maybe wrong on some assumptions. I thought, well, the similar idea applies to air cleaning, right? And so we thought, well, can we develop an air cleaner based on similar principles? Sure, ideally, you want a HEPA filter. And maybe if you don't have a HEPA filter, you have a MERV 13 filter. These are effective filters, right? They have high removal efficiency. I think it's sort of logical to think, like, let's get the things out of the air each time you pass air through the filter. But the other side of it is, well, maybe you accept a lower efficiency if you can move a bunch of air through it, or if it's the only thing you have available to you. So that sort of thinking about, early on in COVID, the utility of cloth masks combined with the September 2020 fires in Portland, where even if you wanted a high efficiency, filter, or even if you wanted a MERV 13 filter to build a MERV 13 box fan combo, you couldn't get them. Like, you couldn't get commercial portable HEPA filters. You couldn't get MERV 13 filters. They just weren't available. So sort of having those two experiences, and I sort of thought, well, what if we try the equivalent of a cloth face mask on a box fan, right? And so some students worked with me. It was a fun project. We basically said, like, how simple and how quick can we make an effective air cleaner? So you see a picture of it here, right? This is what resulted of just some, like, having fun in the lab. We grabbed a box fan. My mother-in-law, who's a brilliant seamstress, sewed me some essentially giant socks out of cotton batting. So she sewed them into a tube. We folded over the other end of the tube and sealed it, quote unquote, with a rubber band, and then ratchet strapped the open end to the box fan. And this picture is with the box fan operating. So it's sort of inflating the cotton sock that we created. And it's actually a pretty effective air cleaner. We got 125 cubic feet per minute of clean air for PM 2.5 when we tested this device in some bedrooms. And so we wrote that up, submitted to the EPA, and it was one of the 5 winners. And so we're going to get to continue developing this, and the EPA will be confirming our results and testing our prototype, hopefully this summer.
And then that you now have another project you're working on. Is this the one? I make sure I have it right. Household atmospheric dynamics under elevated smoke.
That's right. Yeah. So, sort of what finishing work, thinking about this proposal, my partner and I were trying to come up with good acronyms for our proposal. And so Hades is the result of household atmospheric dynamics under elevated smoke. And I'm reasonably convinced that that was in large part why we got the proposal, because I think it's a good acronym, if I say so myself. September 2020 in Portland, it certainly felt like we were, down hanging out in Hades there. So yeah, that's a project that focuses on, the similar ideas. How do we develop a suite of interventions that can dramatically reduce our exposures to the emissions of wildfires in the context of this project is sort of in urban centers that might be, in a wildfire plume for substantial periods of time.
We're going to run over about 5 minutes. Is that you able to stick around with us?
That's great.
Okay, let's go to the roundup, John. The Roundup is brought to you by April Air, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. April Air, healthy air, healthy home at aprilaire.com. All right, I've got a couple questions the Z-Man put in here, and then I want to get to these text questions from our audience. But let's start with any recommendations for what homeowners can do after a wildfire to clean up the soot and the particulate left behind. So the stuff that's not in the air anymore.
Yeah, that's a really good question. And, I've mostly thought about this problem from a standpoint of, buildings that are not, directly impacted by fire damage. And so, certainly soot can travel long distances. In September 2020, for example, there weren't sort of large visible soot particles that I think were present in the plume because it was far enough away from us. But, certainly post-fire, I think there are some cleaning activities that can take place, whether or not there's like soot accumulation or not. And I think they run a range of interventions for air and for surfaces that can all work together. I think one is to continue using air cleaning systems post fire, ventilate your building, run air cleaning systems, ideally with high efficiency filtration and systems that clean gases as well. So like benzene levels might be elevated post fire, for example, and carbon can do a good job removing benzene. So while you're sort of figuring out, what cleaning activities you might do, keep running those air cleaning systems, ventilate as you can. I think if you're able to wear good PPE while you're cleaning, I think that's a good idea. Like an N95, a well-fitting respirator is a good idea. Vacuuming with a vacuum with a HEPA filter, so you're not just, creating an emission source while you remediate. If you're susceptible or have, health issues, you might consider, you not be the person to do these cleaning activities, right? I think another one that, I think we need a little more data on, but I think, it might be a good idea to swap out your filter post-fire, especially if it's a long-lasting, persistent fire. That's one of the topics of the research project we're working on. And obviously the whole purpose of your filter is to remove particles from air, but those particles can contain, a variety of compounds that could be volatile enough to sort of slowly re-emit from the filter. That's a question we're studying in our research project. And I think at this moment, if you have the means to do so and it was a long fire, I mean, maybe for the $20 or so that it might take to replace your furnace filter or the filters on your air cleaning systems, I think that's probably a worthy investment. The last question, the last thing is sort of like, what other surface cleaning might you do is one that comes up a lot. And it's one that, I think my group is actively researching. I know there's been, some work on this. There's some products on the market for cleaning surfaces. And at the moment, I think, soap and water, or maybe some, relatively straightforward, typical cleaning products, it recommends sort of cleaning horizontal surfaces with those after the fire as well.
Well, and there's also, this is a good topic, and I'm going to get you and Cliff together on this, and I know we've got some listeners that deal with this as well. Sometimes you want to use a dry removal method, and then maybe a combination and going in with a wet removal method. So I think that's a good topic for you and Cliff to talk about. Maybe we'll get you back after you a little further down the road with your studies.
Yeah, that'd be great. I'd love to talk with him. I know you were saying he has a lot of experience in this area.
A ton. The other thing is, do you have any recommendations for sampling surfaces after a wildfire? A lot of times our listeners, they're restoration contractors, and insurance company will say, well, that doesn't need cleaned, or, how do you know that needs cleaned?
Yeah, right.
What do you do as far as surface sampling?
So that's a really interesting question. And it's one of the thrusts of the project that got funded by the EPA is we want to develop a low, a relatively straightforward, let's say, sampling method post-fire, right? And so there's precedence for this in the research literature, where you can sample from non-porous surfaces in an indoor space. And so we've been testing this method. And if you take a wetted wipe with some solvent and you wipe a glass surface, you can recover a meaningful fraction of the lower volatility organic compounds that might persistently be on a surface. So glass is a good medium because it's non-porous, and you can sort of swipe it relatively easily. And so we're working on developing that method, but we also, wanted to look at other indoor surfaces. So it's an interesting early finding is that we've been trying this method on painted drywall as well, right? Because painted drywall covers a huge fraction of indoor environments.
Big fraction, yes.
And so the idea is, well, if these low volatility organics are partitioning to drywall, what are they doing, right? And so question one is, well, can we get them back if we just swipe the drywall with a wetted solvent? And what looks to be the early answer is no, we can't, right? So what we're doing is we're doping known quantities of what are called PAHs, polycyclic aromatic hydrocarbons, onto painted drywall. So we know how much we put on there. We're going and doing this wetted solvent wipe on drywall, and we can't get them back. We can get them back from paint or from glass, but we can't get them back from paint. So we're convinced that it's not a problem with our method, but rather PAHs are, sort of stickier, if you want to call it that, on painted drywall. So that's sort of like, it's an interesting finding, I think, because it sort of cuts both ways, good and bad, I suppose, right? Maybe they're, persistently removed from air. They're not going to partition out so easily, but, it might be more difficult to, remediate that, or maybe you don't need to, right? I think there's a need for more research on that topic of, where are these semi and lower volatility compounds going in your space? And then, over the subsequent months to years, is it a problem, right? And how do we remediate for it? So, we're working on it. I think there's probably more questions than answers at this moment, but, I think, over the next couple of years, we hope to have, some guidance there of at least how you might, sample some surfaces and get some information back on that. It does require that mass spec, right? So you need to have access to like a GCMS facility to be able to do those sampling methods.
And there may be other things you could sample for that would be easier, soot particles, etc. I know people do some sampling for that, but that's something we can talk about later. Let me go back to a couple of these audience questions. Elliott, your research is very important for establishing levels of filtration, which should be used in schools. Would you care to comment on Ed's conclusions with respect to the justification for MERV 13 in schools based on health-related evidence? One, MERV 13 is only supported when there are strong sources of fine particulates outside, and two, MERV 13 is not supported for reducing COVID transmission.
Okay. Yeah, that's
a tough one.
That's a tough one. I mean, I think to to get into that, I think we'd probably need some time and some opportunity for me to hear more about, where it sounds like these are your conclusions is what you're saying. And learn more about where you're coming from with that, and learn from you on that a little bit. I'd say, MERV 13 as a bump from MERV 8, is probably a generally beneficial move for indoor air quality, in part because, even if there aren't outdoor sources, it's going to do a better job of removing indoor sources of particulate matter. If the system can handle it and you're not dramatically reducing airflows and things like that, I think there's probably a benefit there for indoor air quality generally, more broadly, than whether or not there's fine particulate matter outside, because there's also fine particulate matter inside. So I'd love to chat with that a little bit more on what you're thinking on that. But
put you and Ed in touch and
yeah, sure.
Follow up later. The other question, my computer just froze up on me, so I remember one was, what are your thoughts on maybe positively pressurizing a room in a wildfire situation to keep the smoke out from the first place?
Yeah, right. No, I think that's an interesting, I think, valid approach. And I know there's a research group working on developing what they're calling a DIY low-cost air cleaner that does exactly that, right? I really love these sort of like, just let's get out there and do it type, research groups who are putting actual things together. So they sort of had built their own, like, think of it as like a window unit air conditioner. So their idea was that you stick this thing and seal it well into a window. And it's not an air conditioner, though I think they're saying that down the road they might like to add cooling, because obviously during a fire, heat and fire are often, together. But they had a carbon scrubber, and I think I don't remember if it was MERV 13 or MERV 16 or whatever, but carbon and mechanical filter positively pressurize the space. And that was exactly their approach, right? Now we know where the air is coming from, we know it's treated, and we're slightly positively pressurizing this space to try and maintain, exfiltration from the space and bringing in air from outside that's been very well cleaned.
And any comments on the current issue of ASHRAE? Gaseous air cleaning is being used to justify reducing ventilation under the 62 IAQ procedure.
Yeah.
Based on spot measurements of a few VOCs.
Yeah, I think it's a great comment, and I think it's an issue. Yeah, it's concerning to me, right? I mean, we know really well that outdoor air ventilation. Now, obviously, there are cases where outdoor air ventilation needs some more attention, like the one I brought up. But broadly speaking, bringing in more outdoor air, we know to be a good thing for the occupants in the building, and we're not, generally near the threshold where you get, minimal deltas in some benefit with more outdoor air. So the idea that we should reduce outdoor air, sure, there's energy savings. I think it's an approach that we should be studying and using carefully maybe in certain circumstances. But I do think it's a big concern if we're talking about technologies that are, sort of in part marketed because they'll save you money by reducing outdoor air, when I think we really need to do more work on checking those underlying assumptions of whether we've addressed what we're claiming we're addressing. Because from my thinking, more outdoor air, we're still in a regime where more outdoor air is a good thing. Obviously there are issues we need to address that go beyond just piping in as much outdoor air as possible, but it's something we need to sort of delicately manage, right? And I don't think we're there yet.
Okay. And one final one, what about using alcohol wipes with charged cloths, I guess, for
sampling?
Yeah, I think so.
Yeah, I think that's on the same track that we are. In the research literature, there's lots of papers that take what's called a Kim wipe, which is just a lint-free like tissue, basically, think of it like that. And you can make these yourself, right? You sort of, apply solvent like isopropyl alcohol, dichloromethane. There's a variety of solvents you can use, but, including alcohols like you're talking about. You can also buy them from manufacturers where they're sort of pre-made wipes intended for this purpose of swiping for sampling. But I think where John might be getting at, and I'm agreeing with this, I have the same thought, is, well, maybe a low cost cleaning approach for vertical surfaces or horizontal surfaces as well is, ethanol is a pretty good solvent for polycyclic aromatic hydrocarbons, or many of them. So, you can get ethanol in large quantities pretty cheaply. So perhaps that's, one low cost remediation method that, you might think about. And that is something that we're studying.
All right. One other one here. Do you think, and Tom, thank you, because this kind of is right up Elliott's alley here. Do you think schools will add commercial grade air quality monitors that will measure top 10 parameters of indoor air quality? I know this is something you're teaching on right now, is these low cost monitors. Is that, or am I wrong?
Yeah, no. So certainly we do work with low cost air quality monitors. They're a great tool. I think it is coming. I think buildings in general will be much more broadly instrumented, not just for carbon dioxide, but other air pollutants. There are good monitors, that can give you meaningful relative information. So how does today look compared to yesterday? But if you do a little bit more work, you can also get good information on absolute levels. So like how much particulate matter is actually there. So I think that's coming.
Okay. And just a quick comment from Ed. Testing surfaces for contaminants cannot distinguish wildfire residue. Marty King and he developed a much simpler method based on soot ash patterns visible by optical microscopy. Again, I'm going to put the two of you together after the show.
I'd love to talk with them about. So our approach, we're targeting PAHs specifically, and so one way that we'd look to attribute it to fires would be to do like pre-post sampling, pre-wildfire, after the wildfire. But absolutely, like PAHs come from lots of places, right? Yep. So our focus on PAHs, there is that question of, what might be confounding our ability to say that this building is contaminated with PAHs from a wildfire versus any number of other things. If someone's a heavy indoor smoker, you might find a lot of PAHs, and you can't blame a wildfire for that, for example. So yeah, Ed, thanks for that. I'd love to chat with you about what you've been working on.
All right, Dr. Elliott Gall, is there anything we missed? Anything you'd like to add? It was a great interview, got over a lot of territory. I didn't think we'd make it, but I believe we covered most of what we wanted to.
I really appreciate the chance to talk and, share some of our work. I appreciate, there's a lot of folks out there who've been doing this a long time, and I really mean it when I say Ed and some of the others. I'd love to email or chat. There's a lot that I'd love to learn from this community as well. So I appreciate the opportunity.
All right. Well, this is Radio Joe Hughes saying thanks to this week's guest, Dr. Elliott Gall. I want to also thank John. You got to have faith at the controls. Of course, my co-host, the Z-Man, Cliff Zlotnick. Most importantly, our growing group of sponsors and our growing audience. And happy Earth Day. Thanks, Vic. Very interesting show, and happy Earth Day to you as well. We'll be back next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.